Hi everyone. Today we're going to be analyzing a complex capacitor circuit. Well, first let's talk about what we mean by complex. What I mean by complex is that I have multiple branches. We see here two capacitors that are in series with each other. They are in turn in parallel with a third capacitor. So what I need to do is I need to simplify this into not quite as many branches. So the first thing I'm going to do is I'm going to simplify these two that are in series with each other. To do that, I'm going to find their equivalent resistance. Equivalent capacitance. So the way I do that is I take the reciprocal sum of capacitor 2 plus capacitor 3, or 1 over 32 plus 1 over 58. And I'm going to hit that into my calculator. 1 over 52 plus, 1 over 32 plus 1 over 58, and that gives me 0.0485. But I have to remember, that is not my answer. That is 1 over my answer. So to find my series capacitance, I have to take the reciprocal of that answer. Which gives me 20.6 microfarads. Now that answer should make sense because when we have capacitors that are in series with each other, the overall capacitance drops because the distance is now the total distance between them. So we should have a lower overall capacitance. So what this is saying is that those two capacitors, my 32 and my 58, can be represented by a single capacitor of 20.6. So now what I'm going to do is I am going to redraw my circuit. There's my battery. And now I have a parallel branch. With my 20.6 microfarad and my 76 microfarad capacitor. And my battery is still 4.5 volts. Well, now I basically just have a parallel circuit. So I am going to add those two together, because in parallel, we just do the direct sum. So capacitor 1 plus my series capacitors, that gives me 76 plus 20.6, or 96.6 microfarads. And that is my equivalent capacitance. Okay. You might want to take a moment, pause the video, go back and resolve it on your own. Okay? All right, for our next part, what we are going to be doing is we want to find the charge and voltage on each capacitor. So to do that, I'm going to look at my redrawn circuit. And what I see here is that I've got a parallel circuit. Well, I remember that in parallel, charge varies, voltage is constant. That means the voltage on the 76 and the voltage on the 20.6 is the same. And it specifically is going to be my battery. So if I'm making up a little table, which I like to make a table for this, I'm going to say voltage 1 for capacitor 1, Q1, and then I'm going to say voltage series, Q series. Okay. Voltage 1 is going to be 4.5, same as my battery. Voltage for the series is going to be 4.5, same as the battery. I'm now going to find what the charge is. Q is going to be C times V. I'm first going to find my total. I have a specific reason for doing that. So my total is going to be my 96.6 microfarads, so that's 10 to the negative 6 farads, times the voltage of my battery, 4.5 volts. So my total charge in my circuit is going to be 4.35 times 10 to the negative 4th coulombs. Okay, I have a background reason for wanting to know that. I'm now going to find Q1 and QS. I'm going to find them the same way, C times V. So Q1 was 76 microfarads. Its voltage is 4.5 volts. 76 to the negative 6 times 4.5 gives me 3.42 times 10 to the negative 4th coulombs. I'm going to write that down. Q in the series was 20.6 times 10 to the negative 6th farads times 4.5 volts, which is 9.27 times 10 to the negative 4th coulombs. Now, the reason I did that is I want to check that I'm doing this correctly. To do that, these two should add up to my total. So 3.42 to the negative 4th plus 9.27 to the negative 4th. Oh, I'm sorry, this was to the negative 5th. To the negative 5th That gives me 4.35 times 10 to the negative fourth. So I know I did that correctly. Okay. Now that I have that, I'm going to remember that my 20.6 microfarad capacitor really was two capacitors in series. Now, in series, what's constant is my charge. So the charge on the 32 is the same as the charge that's on the 58, and that charge is what we just found, 9.27 times 10 to the negative fifth. So I'm going to make a little bit of space for myself here. And now I'm going to solve for that series voltage. Okay, because in series, charge is constant, voltage varies. So we said that Q was equal to C times V. That means V is equal to Q divided by C. So 9.27 times 10 to the negative fifth divided by, first, my 32 times 10 to the negative sixth. And then, so that's going to be voltage 2. And then 9.27 times 10 to the negative fifth divided by, was it 58, times 10 to the negative sixth. So let's plug those in. 9.27, negative 5, divided by 32, negative 6, gives me 2.90 volts. 9.27, negative 5, divided by 58 to the negative 6, gives me 1.60. Now, just like I could add up my charge when I'm in parallel and check that I'm correct, I can add these two up, and that should give me 4.5 volts. And if I do, 2.9 plus 1.6 does give me 4.5. So I know I did that correct. So I can say what the charge on the two of them are. I can also say what the voltage is. 9.27 to the negative fifth. 9.27 times 10 to the negative fifth. And my voltage was 2.9. And this voltage was 1.6. And that is how we analyze our circuit. Okay? Hope you enjoyed the video.